Good morning, everyone. Ellarigu namaskara. Myself Husna Sultana, Assistant Professor in Computer Science, Government First Grade College, Tumkur. Today, I like to teach you the subject Computer Hardware and Networking, which is prescribed for BCA first year, first sem in Tumkur University. In this subject, there are totally 6 chapters. And each chapter will be give you the brief introduction about all the concept. It cover all the concept about the computer as well as hardware and networking. And in this concept, you will understand there are totally 6 chapters. In that, introduction to computers is there, input output devices is there, chapter 2, chapter 3 content memory management techniques, chapter 4 content computer organization and architecture, chapter 5 content computer network, chapter 6 content transmission media and network devices. In all this chapter today, I like to discuss with you the chapter 1, which is basically related for introduction to computer. In this chapter, you will learn about introduction, history. This is the objective of this chapter, where you will understand about introduction, history of computer, block diagram of computer, generation of computer, classification of computer, as well as characteristic, application, human interface with a computer. And along with you also get a brief introduction about types of softwares, operating system user interface, utility programs, as well as number system. This is what just now I told you. So let's understand the definition of a computer. What is a computer? You know very well, computer is an electronic device which accepts data, process data and display the result. This is the basic general definition for the computer. It is one of the important device, or we can also call it is one of a device which help the user not only processing, not only for storing, it also help the user to display as well as to store the information for our future purpose. Okay, it is one of the device which similar to like it is a machine, but it acts like as a human being. Nowadays, due to this lockdown, this computer plays a vital role and it helps us to do a lot of tasks. You know very well. Let's understand the other basic concept of this computer, how this computer evolved, how the computer has been introduced, who introduced. We will understand the basic concept. Functions of computer. What is the main function of computer? As just now I told you, in definition itself I told you. What is that? Computer is an electronic device which accepts the data, process the data and display the result. That is the main functionality itself. Not only the definition we can sell, it's the function. A main function of the computer is used for calculating, performing mathematical and logical operation automatically, and accepting the data by using input device and processing the data by using processor and displaying the data on the your screen or on the output devices using output devices. Then let's understand a brief functionality of a computer. Accept the data, just now I told you, store the data in instruction, process data in instruction, output the resultant information. So let's understand the characteristic of computer. What is the characteristic of computer? Obviously, why we like the computer? Because it works very enormously. Means we can't imagine. With a fraction of a second, we can do the multitask as well as we can send the information from one device to another device. So that means what is the main characteristic which help us to do help the computer to do this all tasks? Like speed, accuracy, versatility, storage, reliability, no feelings. What does mean that? No feelings mean no, it's not a human being, it's a machine. It doesn't have sensitivity. Okay, speed you know very well. Accuracy, the perfectness of a computer. Versatility, it never get tired. Storage, it helps the user to store huge amount of information and it allows the user to work continuously. So we have understand the functionality, the characteristic and definition of computer. So let's understand how this magical device has been invented. What is the history of this computer? The history, when you began the history has been generally to be tell. We have divided this history of a computer in three eras: mechanical era, pre-mechanical era, and electromechanical era. Then electronic era. Okay, we in history of computer, first we called pre-mechanical era, then we called mechanical era, then electromechanical era, then electronic era. When you come for pre-mechanical era, in the olden days, or don't go for olden days, even now also, if you want early, if you want to do any mathematics or calculation, and if you want to teach your friends, or if you want to do a simple addition problem or subtraction problem when you are in the childhood, when you are learning the addition or subtraction, what generally we don't use the calculator or we don't use the any other devices. We want to use pen and paper. Along with the pen and paper, we want to use our brain. So at that time, the simple logic, what we are using, we are putting the lines for to add, and we will use the lining concept, which is basically our when we are in the pre means when we are in the pre-education stage itself, our teacher teaches how to perform the addition when they have given 2 or 3 digits by putting the lines on the sheet or by using our fingers how we can count. So this is the basic concept of counting, which was there in case of pre-mechanical era. They are using fingers, stone, stick for counting as well as at that time, there is no device to perform or to store the information for counting. They generally, based on the nature itself, they will predict the time. Based on the quantity itself, they will tell this much of the weight. Like this, the people were there. They are very sharp because they are very hard worker. They are working from morning to evening and they are doing the certain occupations which at that time education illiteracy was more and education is less, but the working knowledge is very fantastic and they will using a concept called for counting. They are using the concept like fingers, stones and stick, and they were using pebbles also. Nowadays also our grannies will use certain pebbles or anything for counting and for example, if there is a one game which are using to count and play like pebbles game, so this type of thing they are using in case of pre-mechanical era, and it is from 3000 BC to 162 AD. Approximately, it is around 4,000 euro, which I am speaking with you. But still, no, we are in practice. We are in practice because that is the basic thing which is used for counting. And at that time, the Chinese people, in order to improve the way of counting and to improve the mathematics, they introduced a machine called abacus, which is used for addition as well as subtraction. And they later on many devices also been introduced by using what we called Napier bones, which is used for multiplication and division, and then there is also they introduce the other devices like what we called in pre-mechanical era. They also introduced a device called that, like for example, slight calipers you are measuring in case of your lab, the slight calipers which is used to measure the thickness, a small thickness. In the same manner, they at that time they have introduced many mechanical devices which is used for calculation. And they had used John Napier bone. He used the bones for performing multiplication and division. Like this, this is the pre-mechanical era. Later on, there is a due to time short pin. I am telling you only some examples of pre-mechanical era. And when you come for the mechanical era, here it has been started from 1623 to 1820. Here there are a large number of mathematicians are there. They are working based on the principle of Abacus. At the time, a person called Blaise Pascal. He's a one of the person. He's a famous mathematician as well as a philosopher. In the year 1642 and 1644, he introduced a machine called Pascaline machine, which is used to perform an addition and subtraction, which is one of the, and based on this principle, they have introduced a machine called calculator, which now basically we are using. This machine is working basically simply on the concept of calculator. As calculator, which we will use for addition and subtraction, multiplication, division, everything we'll do by using calculator. In the same manner, at that time, this is one of the person who is responsible who introduced a device called Pascaline machine, which is used for addition and subtraction using numbers as well as manipulation. And then it has been updated and many devices has been introduced during that period. There is a German inventor called Gottfried. He called a person called Gottfried Leibniz. He introduced a machine called Leibniz calculator, and which helped the user. It is the updation of Pascaline machine where you can do the minute calculation, fractional calculation, as well as later on an English mathematician by name Charles Babbage in 1820 he implemented this Blaise Pascal machine concept. He updated this concept and he introduced a mechanical device itself in the manner of a machine called difference engine, and this machine is used for using for simply printing as well as calculating the mathematical tables. He's the uh, Charles Babbage. He is one of the he introduced the basic concept of what we call as an computer, so we called him as the father of our computer. Okay. And when you come for the electromechanical era, it was started from 1840 to 1940. In the previous era itself, I told you, the differential engine has been already introduced. It has been updated in this era, where the punched code concept has been introduced, which is used for input as well as to show the data. The display device has been introduced, as well as there is also they introduced a simple concept for storing concept. The storing of permanent memory concept also they introduced by updating the differential engine. So that engine we call as an analytical engine, and it was being used for census in case of British people, and it got success during 1840 to 1940 period, and we call this as an electromechanical era. And during this period, the first electronic computer called Mark One, that also been has been introduced by a company called IBM, and it is around which we call as an automatic sequence calculator, what we call as an automatic sequence control calculator, and it is around 51 feet long, and the weight will be 4,500. 1,500 kgs, and it perform addition, subtraction, as well as it helps the user to perform multiplication. To perform a simple multiplication, it will take 6 seconds to 14.3 seconds, as well as it helps the user to perform logarithmic concept, and it got success. And then the electronic era in this time period, When we come for the electromechanical era itself, there is a lady called Lady Ada Lovelace. She introduced the programming storing concept. She introduced the machine language. She is one of the first programmer. She is a lady called Ada Lovelace. She is the first programmer who introduced the programming concept, and at that time they are using only machine level language. And then next it comes to the electronic era, where this concept had updated, upgraded, and they introduced digital record keeping concept and high tech global company as and many individual explored means it has been updated, and many computers has been introduced at that time. We will understand how the generations will be. This is only a brief history, so which I am giving you, telling you what is the things, how it will be changes. Okay, and it is an high-tech global company, has been supported for this, and it also support the individual to explore their personal needs by improving this electronic era, where the digital concept has been introduced and many updated programming language has been introduced, and it is one which lead us to introduce the computer which we are using now. At present, what we are using in the that computer is totally which is called as an electronic and digital era. Now let's understand generation and classification of computers. So when you come for the generation, as we have got the a brief, what you call a brief idea about the history of computer. So it has been divided into a generation of computers. So as we know, the first itself, it has been 1980s itself. The concept has been started and it has been updated, and successfully it has been implemented in case of 1946 to 1954. And the first generation of computer, as I told you, Mark 1 is the first computer. They has been introduced by the IBM company. At the time, they used a computer. What technique they have used, what technology they have introduced, they are using vacuum tubes to build the computers. And you know, vacuum tubes, it's which is built on the it is built on the principle of cathode ray tube, okay, which consume lost number of energy and it produce the heat. And here the memory they will use magnetic drum, and the programming language they are using as machine language. And the main drawback here, we'll see it occupy more space and produce more heat, and it is very difficult to understand the programming concept. If any error come, it is difficult to rectify, and whatever the result will come is also not so accurate and very expensive. Common people cannot afford. When you come for the second generation, it is from 1946 to 1954, and they have modified, instead of vacuum tube, they replaced it by transistor. Vacuum tube was replaced to transistor, and it is one which is very advanceable, and it reduces transistor. You are all aware, and the size of the transistor is very negligible compared to vacuum tubes. Obviously, it gives a plus point where the size of the computer has been reduced, and instead of the punched code concept, they introduced magnetic core for main memory concept, and it got success. And punched card will be used only for the input. Core memory is using for the storage device. And they updated from machine level language, they also updated assembly level language has been introduced for programming, and it is become smaller and in a little bit expensive, little bit, not so cheaper and not so highly expensive, in between moderate cost. And even though it is moderate cost, a common people cannot afford because there is certain drawback. Storage capacity is also very less. We will understand later on when you see the generation of computer, and it is very smaller and hence it is portable. And here you can see the language in that time itself. Before going for third generation, in this generation itself, a COBOL, BASIC, Fortran, like this language, which we call as a high level language concept, already has been introduced, and it is meant for only certain purpose, which I tell you when I discuss the third generation of computer. Third generation of computer is a miracle. The transistor has been reduced. Instead of transistor, it was been replaced by ICs. And here we will use the what we call size of the computer has been reduced, the speed of the computer has been improved, as well as generation of the less heat, and it's work very faster, lesser maintenance, and it's not, little bit costly only. Compared to nowadays computer, it's very costly, and for this computer, AC compulsory. Without AC, you can't work because it consume more number of heat. Heat will be produced, and it consume lesser electricity when compared to the previous generation, and it support high level language. As I told you in previous, already they have introduced basic, COBOL, Fortran. So like this language had got success here. The basic is for beginner all purpose, COBOL for business oriented, and Fortran for Pascal. And they are at the time the C language also has been introduced, and operating system concept has been introduced, and the compiler, interpreter, as well as assembler has been also introduced at that time. And the next, when we come for the fourth generation of the computer, and whatever the drawbacks in the second generation, first generation, third, it has been completely overcome, and they introduced microprocessor based system. And microprocessor instead of IC, they replaced by a microprocessor, which is easily portable, and because of the smaller size, it can easily carry anywhere. Now, whatever the computers we are using, it's similar to that size, and it hardware failures. Even the hardware failures, we can afford that. As well as it support the networking. Networking concept has been introduced. That is one of the plus point in fourth generation, and speed, accuracy, reliability of the computer has been increased, improved when you compare to three generation, and the input output device are so well developed. And for this generation computer, no AC, not required of an AC, and the concept of introduce was introduced this time. And when you come for the fifth generation, 1946 and 1954 is the era where you can recognize images, graphs, you can solve a very tough problem, you can easily solve. Facilities, decision making, logical reason. You can easily decide, you can take the decision. Means AI concept has been introduced. To be short, AI concept where it has been not completely what we call it, so completely AI concept, but here the generation, when you tell, it is like very low scale integration, super large scale integration, that concept has been introduced. So it support generally it will be used in weather forecasting, as well as medical fields, and as well as in news media. This computers has got success, and it has been, now we are successfully using. This is the basic things which at that time there. And when we come for the classification based on purpose, the computer has been classified in case of general purpose and specific purpose computer. Classification based on principles. There are three principles that majorly they divided: analog, hybrid, and digital. When you come for the analog, those computers basically based on the changing of the physical quantities. The computers which is based on the physical quantities, like that is depend upon the analog signals. That's why it totally depend upon the physical quantities like temperature, pressure, etc. For example, if you want to measure your body temperature, you will use one device which only used to show the what is the temperature at present you have. So, or if you want to, for example, if you want to check the pressure of your tire, you go for, in case of a petrol bunk, if you go petrol bunk, you will check the pressure, and you will adjust your pressure, and you will check your tire pressure in normal. That type of awareness may, it only it's showing. And when you come for the analog computer, one the best example is the ECG checking machine, where you can see based on the analog signals, it measure our heart rate, whether it's working properly or not. And when you compare, but it is not so very fast and not so accurate, and it is one which help the user to measure continuous on based on only physical magnitude. When you come for the digital computers, and these computers are those which work on zero, that is binary language. With the computers which will be work on the machine level language, those computers we call it a digital computer. And these computers will give an accuracy of the results in very fast rate, and it is one which has been classified into general purpose and specific purpose computer. Okay, and it is one which helps the user to use as well as to work with the numbers. When you come, just now I told you the digital computers. One of the example I had told you for digital computer is that is when you're checking the weight, when you want to check if you want to stand up on a weighting machine, it will show you automatically based on the weight. It will show you the numbers in the manner of numbers. It will show the digital and it will display. It also printed a card also where you it will get a weight of a person. So this type of working machines we call as in digital computers, and you can see hybrid computers. When you come for hybrid computers, it is one which is nothing but the combination of both digital and as well as analog concept. And these computers are normally we use in our health fields. In case of health field as well as in case of analog signals, when we see, we also use in weather forecasting. When you come for the health fields, you can see this hybrid computer in case of ICU, where and there is one machine which is showing the pulse rate as well as temperature of a human being, and there is also one machine which is showing the variation of the pulse rate in the manner of signals. So those type of machines which is working on the concept of both analog as well as digital combination, those computers we call as an hybrid computer, and it is used for automatic operation, and it is a little bit complicated when compared to physical process and machines. And next we will understand the classification based on size and speed. Here there is certain when you come for the classification of a computer based on size, you know size means the variation of the size as well as the speed of the computer. The first is microcomputer, which we also call as an then actually when you come for size and classification, mini, main, micro, super, like this we will divide. Okay, so here we will understand the first concept is microcomputer, and when you come for the microcomputer, it's generally nothing but our PCs nothing but personal computers which we are using. It contain all input, output, storage device as well as processor, and these personal computers are also called desktop computers or portable computers. Portable, which is nothing but an example we can call laptop, notebook, whatever we are using. Even now our mobiles are also acting like a portable computer itself. Okay, and desktop computer which we are using in our colleges as well as in our schools, in our homes. When it comes to the mini computer, the size little bit larger when compared to the micro, and it's more powerful than personal. And these computers we will use in generally when in the bank sectors as well as in company sectors we will use. And speed here, thus compared to that microcomputer, the speed is 5 million instructions per second. Mini computer can serve up to 4,000 connected users simultaneously. Note this. Mini computers help to serve up to 4,000 connected users at a time. Okay, it supports that type of operating systems. Operating systems which used to support. Later on, you will understand that subject itself you have where you will understand operating system. These computers will support that type of operating system where it served for up to around 4,000 connected users simultaneously, and there are number of processors here in mini computer. In that minimum at least there is one or two processor. Mini computer means it doesn't work on only one processor, it's work on minimum at least two processors will be there. And when you come for the mainframe computer, these are very large in size compared to micro, mini, and it is more powerful and very fast processor. It's mainly used in case of weather forecasting as well as in case of banking database management as well as in certain hospitalization. They are using in research centers they may use, and it consists of multiple processors. So you can observe the difference. In our desktop and personal, we are using only one processor. When you come for the micro to mini, it's increase the size of the processor. A processor is nothing but a brain of the computer. Here, you can observe mainframe, it's one which is working on multiple processor. And it used to design, perform multiple tasks for multiple users at the same time. And the next is supercomputer. A supercomputer is the fastest computer, biggest in size, most expensive, and it is more sophisticated, complex and advanced computer, and it is very low storage capacity supercomputer play and very important role in the field of research as well as weather forecasting and RAM. SP RAM, Super RAM, this computer is one which has been found out by our Indians, that is IBM company, the supercomputer which successfully we are using. Okay, and here you can see these computers were one which is one, it can be used in case of like research and exploration purpose, and like NASA, as well as in case of launching satellites, as well as in case of hospitalization, and it is one of the computer which is mainly used for weather forecasting, climate research, as well as in chemical factories. Okay, and these computers do its job. Compared to all this, it's you can't imagine the speed as well as the work of this computer. And the next is digital computers, and those computers which work on zeros and ones, they give the result with accuracy at fast rate, unique, and it is similar to like your general purpose and specific purpose. And I just now I told you hybrid computer, and let's understand the block diagram of a computer and its applications. So see, this is the block diagram. I just in definition itself I told you computer is an electronic device which accept the data, process the data, display the data and store the data. Okay. So in this concept you can understand it accept the data by using an input unit, that is keyboard or mouse, and it help the user to process by using processor which contain control unit and ULU, and also it contains storage unit which is consist of secondary storage as well as primary storage, and there is also an output unit which used to display the result, whatever the data you process it will display by called monitor and printer. Okay, so let's see. In input device, help the user to accept the data, to solve any problem. As just now I told you, it help the user to accept the keyboard and mouse. CPU is the brain of the computer. It carry out the instruction. It read and write, execute the instruction. It consists of ALU, control and registers. And there's a memory. Memory has been divided into two units, primary and secondary. That will be there and store the data instruction, internal results and output temporarily in primary memory. But if secondary memory is there, it's stored permanently. And there is arithmetic logical unit which help the user to perform arithmetic and logical operation like addition, subtraction and decision making. And there is also control units which control and coordinate all the units of your computer, that is input device, output device, as well as there is also yeah, it is one of the main unit which help the user to control all the hardware operations. And there is also very important unit called output unit which is to display the result like monitor and speaker as well as printer. Let's understand the applications of computer. Applications of computer, you know very well, computers will be used in every field. Nowadays, without computer, we can't live like that. It is going on. Okay, so we can use computers in education, healthcare, entertainment, engineering design, business, military, banking, research and development. You know, the computer first they introduced in case of defense itself for the defense purpose as well as for health purpose and for research itself. First they are using in that sectors only. Later on it has been updated and it has been implemented for banking sectors. Then it has been implemented for education and previously they first in the first after internet has come, it has been successfully used in entertainment and education as well as in case of multimedia operations. Okay, so there is also different types of, and when you come for the application I need not to do you know everything, you will understand how in education field. Just now I am doing the PPT which helps a lot of students, that is one of the example. In case of healthcare, if you want to do any test or if you want to take an ECG, if you want to test your temperature. And when you come for the entertainment, like in case of multimedia, for making magazines or making news or to adjustment anything, that is entertainment. Engineering, to design the automobile or to design any craft or to design any space a space what we call aircraft designs. And also in case of business strategy, it helps to do online business. And in case of defense, it helps the user to make the use of weapons. In when you come for the banking sector, it helps a lot. Nowadays we can use online banking, the help of the computer. And research and development, you know very well, it's working successfully. These are certain application. Let's understand operating software, types of software, operating system, and user interface. Software, whatever you know, just know you have understand the application, the types of generation, as well as the history, as well as the different types of computer, how they have been classified, how they have been made the generation based on the capacity of software and hardware itself. What do you mean by that software? Software is a set of program which tells the computer to do what. It helps the user. It's a software is divided commonly into two main categories. They are system software, application software. System software is nothing but a collection of system program to perform common tasks, and it is run the basic level of the computer. Like just now I told you previously, they have introduced operating system, and operating system like Unix, Windows, as well as Linux, as well as DOS. This is the basic software at the time they have introduced to run the system, to run the application, to control the application of the computer. So this will install whenever you purchase. Without the software you can't work. Without that particular system software you can't work. Along with if you want to work some extra, if you want to do some extra work, you require application software. Like MS Office is an application software. Just now I made the PPT and teaching with you. This is, and I'm using one software that is also an application software which helps the user to record. Okay, and application means which use only for specific tasks. Whereas for system software, it is generally used for the system purpose. And it when you come for the application, it helps the user for writing letter, viewing the image, preparing invoice, listening music, preparing spreadsheet, and so forth. But when you come for the hardware, based on the requirement, hardware also there is also different physical component of the computer that you can touch, feel, as well as you can use the circuit board and other electronic device to work. The example: keyboard, monitor, mouse. And when you come for the operating system, it is nothing but a part of a system software which helps the user to work with the user interface. It's a set of program. Software itself is a set of program. Operating system is a part of the system software. System means it's a set of programs where which ensure the computer to work with together. It helps the user to interact and to work to perform different tasks. And there are different types of operating system like single user single task, multi-user multitask, and single user multitask. When you come for the single user single task, DOS is the best example. When you come for the single user multitask, Windows is the best example. When you come for the multi-user multitask, Unix is one of the best example. And this concept, we are coming for the end of this concept where there is about number system and the need and classification of this number system. Let's understand. You know why we are understanding the number system? Because our computer is being basically constructed, and I had told you, in case of classification, the computers are digital computer, digital language, so machine level language. It's which totally understand the binary concept, that is zeros and one concept. If you want to understand that concept, then you want to aware about the number system, and which even when we are in the primary schools we have understand, but we should recall that, we should understand how it has been implemented and used in our machine, how they have converted that analog signals, whatever the analog signals they are using, they have converted into digital concept, that is zeros and ones, and they are using in case of our computer nowadays. When you come for the number system, it has been divided into a large number of digital electronics devices, and it is the concept which is used for the binary representation. And in this number system you will understand different classification. So basically, in case of number system, there are non-positional number system and positional number system. A non-positional number system is where you can represent the numbers by using symbols, that is Roman numbers, as well as like uh, what we call as an star, dot, means it doesn't have any decimal place value. Those numbers we call as a non-positional number system. And when you go for positional number system, a numbers which have certain value. For example, if I have written 10 means 10 has certain value. 1 is 10 place and 0 in unit place, that automatically show it's 10. In case of 0, one more 0 if I add, it gives one more, the position of that number increase one level. That is it, the position, it shows the value of that number is 100. Like this, the position varies based on the adding of a number. So this type of representation of numbers we call as a positional number system, which we also called order set of numerical symbols, which is basically we call it as digits. And when you come for the digit of the extreme left and the highest positional value, in this how we recognize, just now I told you one example, that is 10, 100,000. So in how I am recognizing it is an 10, 100,000 based on its place value, that is least significant digit and most significant digit. The least significant digit we call as a unit place. As it is increasing the position place is also increasing. For least significant we call as an unit place value. On the next highest we call as an 10 place value. For the next place value we call 1000, 100, like this. The place value from unit, 10, 100, 1000. The position varies, the number values varies. The numbers we choose to show the position, those numbers we call as a positional number system. In case of positional number system, they have classified based on the number of digits they have used. And here you can see 2 to the power of n number system we can use. When you come for the binary number system, it contain only 2 to the power of 0 means it contain only 2 digit, that is 0 and 1. And when you come for the octal number system, it contains 2 to the power of 3. Oct means 8. 2 to the power of 3 is 8. So how many numbers it contains? It contains only 3 ways of representation number. And it also represented by using, in case of octal number system, we will understand later. So here we will use to represent from 0 to 7. When you come for the hexadecimal number system, it is used to represent 16 digit number where it contains 0 to 15. When you come for the decimal number system, which is basically all human beings are using, it will be a number system which consists from 0 to 9. From using to 0 to 9, we can represent 1 lakh, crore, or million and billion. Okay, so let's understand decimal number system. Just now I told you a number system which used to represent by using 0 to 9, while the radix or base will represent by using 10, the power of 10. And when you come for the binary number system, it is used to represent by only by means 2, the numbers which consist only 2 digits, that is 0 and 1, and the positional values will be expressed in the manner of power of 2. Okay, when you come for the octal, just now I told you, and that is 8 digits, 0 to 7. Okay, and the radix for that is 8. When you come for the hexa, it is represent from 0 to 15. But in case of 15, instead of 10, you want to represent it by using alphabets. For 10, you will use A for 11, B for 12, C for 13, D for 14, E for 15, F. And the position value for this is power will represent it in the manner of 16. And when you want to understand the converting of decimal number into any other number, these are certain steps you want to follow to convert a decimal number into any other number. A decimal number, for example, 25, if you want to 25 to convert into the any other number, first you want to take that number, then you want to divide the number by its base, by showing its seeing the base. So you can divide the decimal number by converting into its base value and note the quotient as step by step. What are the quotient you will get, and the remainder based on that the step 1 and step 2 will be repeated until you will get 0. And while keeping the value, you want to keep the recorder, you should record the remainder from bottom to top, means from down to top. You want to get the final result, and this is one of the example. So as this is 28 is one of the decimal number system. When you divide the decimal number system, if you want to convert into binary, convert into binary, what you want to do? You want to see the base. What is the base you are converting into binary? Binary base is 2. Now this 28 is continuously divided by 2. So we are getting, see, 2 divided 14 is 7 is 3, and we are getting, until unless we are getting this quotient into 0, I got it is totally, I got 0 here. And what will be the remainder? The remainder 0 0 1 1 1. Now when I keep the out means result here, how I want to keep? I am keep to from the bottom to top. So you can see 1 1 1 0 0. This is my output. Sorry, here there is a typing mistake. For 28 they have written 18. Okay. And then next is, there is a converting base 10 to fractional part in any other number. Then you want to use the multiplication of that particular base and take an integer multiplication, and only the fractional part, if you get the fractional part, again you want to multiply by the next step, and this repeat the step for 2 to 3 for 4 to 5 multiplication, and record the decimal part and multiplication. You can see this result, see here. For example, see here, there is a 24.13. This is what? This is a decimal number you are converting into a binary number, and they have given what here? They have given fractional value 13. At that time, the same division you want to do for the 24 as we done in the previous. When you come for the 13, that is decimal value, you want to do repeated multiplication until you will get repeated 0, and while keeping the value as the output, you should ignore the number present after the decimal point, and you keep only the value from top to bottom. There we are keeping from bottom to top. Here you want to keep from top to bottom. What will be the output here? 0 to 0.13. We have multiplied continuously by 2, and we got finally we have the recurring result we got, and so we have stopped in the fourth place value itself, and we have keep the value from top to bottom 0 0 1 0. And for 24, what we have continuously divided and we got the remainder. Here you can observe, I am keeping the value from bottom to top 1 1 0. For here, top to bottom 0 0 1 0. Okay, and finally we got 24 base of 10 is equal to 11,000.0010. When you come for conversion of decimal number into octal number, that is any number into octal number, at that time again you can same as binary, you want to divide the decimal by the base. What is the base here? 8. Now 8 will be continuously divide until you get the remainder 0, and again the value, how you want to keep the value, should be kept from the bottom to top, that is 3732. And now if you got the fractional value, you continuously multiply and the value from bottom to top. So this is how we are using what? The main difference is we are using the base as, there we are using base as 2, now we are using here base as 8, because we are converting decimal into, there we have converted decimal into binary, now we are converting decimal into octal. When you come for to convert decimal into hexa, that time you can see there is 328 we have taken, and what will be the base here? Index is 16. Now 16 will continuously divide until we get 0, and when you come 8 4 1, if I got 9, okay, if I got 10, I don't write here on the letter 10. Instead of that, I will use an alphabet called A B C till 15. Okay, so and here the value will be written as 148 from top to bottom. And when you come for the 31415, that is this is one more number we have taken, and just now I told you in my, while showing you, if you get 10, don't write and 10, you should write A. For 11, if it is B, like this. So this is one more example you can observe, where we have divided the given number continuously by 16, and for the remainder we have got the remainder, and we are representing from top to bottom. For each value we are showing a character. And now we are converting a binary number into decimal number. This is the reverse conversion. There we are dividing, here we have to multiply with the base of that particular number. Which number you are converting, that base is very important. Now you are converting binary into decimal. Binary into decimal means you want to multiply that number by continuously the base. What will the base of the binary number? 2. And then you want to keep the value. You will get the value. How the value should be allotted for that multiplication number based on the power index. For first 0, 1, 2, 3, like this you will give the power value and multiply by that particular number. And the next you can see one more example, that is for fractional. If they have given, at that time you want to, the main change you can observe here is, here the power value will start from 0, 1, 2, 3, 4. But here the power value will be -1, -2, -3 and -4. Like this, it is a negative value, it reducing the position value. Okay, and we will keep the value. Now we can see conversion of binary number into octal number and hexa number. Conversion of binary number into octal number and hexa number. First you want to consider what number you are converting, whether it is a binary or octal. And then if it is a binary, you want to group into 3 sets and 3 bits, and then you want to place the number for that. If it is, and for example, see if it is an hexa, okay, later on I will tell you the example. So if it is an octal number, first you want to group, see the number, then you want to group. If it is an octal, you want to convert into octal, group into 3 bits, and based by seeing the value of the number, you want to keep that number, and you can easily convert into octal. If it is an hexa, you want to group in the manner of 4 bits, and based on this value you want to write the number for that particular value. And it is used while grouping. You should keep in the mind that you should start from the lowest significant bit to most significant bit. And when you conversion of octal number into decimal and binary, you can see certain example here they have given. That is 42 to base of 8 to decimal. That is what, and the binary to decimal itself I had told you what you want to do. You want to take the base of that particular which number you are converting to decimal. That is very important. Here we have taken 8 as base, and then where we have given the power value 4 into 8 plus 2 into 8, and power value for that is 0 and 1, and based on the power value we have multiplied, we have kept the answer. And this is for the fractional, again 0, 1, -1, -2. And now you can see I have told you how to convert the octal number into binary. This is 52 base of 8, and when you want to convert, you can divide it continuously by 2, and you will get. Otherwise, if they give directly binary to octal, then you want to group into 3 bits and you will get the value. And when you come for the hexa, if they have given convert 2, 4, 5 into hexa, then you want to easily you can group the numbers into the binary form. First you want to convert the given number into the particular 3-bit numbers, binary numbers. Then first you want whatever the number give, they want to convert into binary number, then group it into the one form, then afterwards you want to group it into 4-bit form. So you can easily convert into the binary into hexa. Now conversion of hexa into decimal, you can see if they have given, even they have given alphabet, you want to write into numeric value and you want to write the power. And these are certain examples. So we can see here we have converted the hexadecimal into binary, but we have not done the previous as a multiplication or division. We just write there is a table which we want to observe, that is 0, 0, 1, 0, 0, 0, like this. This is the 4-bit numbers. For 1 it is 0, 0, 1, and for 4 it is 0, 1, 0, 0. For E it means nothing but it is 15, E is 14, and 1, 1, 0 for 15, all digits are 1. For C it is 1, 1, 0, 0. Like this they will represent. For this conversion of hexadecimal into octal, you want to convert hexadecimal value into binary value. Then you want to group in the 4-bit, as I have shown you in the octal to the hexa. You want to first convert into hexa, then afterwards you want to group into 4-bit, and then you want to keep the value. So this is how you will do the octal to decimal, decimal to octal conversion. Hope you will understand. Thank you, Anand.